Thank you for joining Smart Science Educators. Today, let's look at grade 10 physics, moments, and equilibrium. Therefore, moments is the product of force and the perpendicular distance from the point of support to the line of action of an object. Equilibrium is the state of balance of an object. Therefore, question number one, the figure shows a drum of mass 150 kilogram and radius 0.5 meter being pulled by a horizontal force F against a step 0.1 meter high. What initial force is just sufficient to turn the drum so that it rises over the step? Before looking at this question, we must identify all the forces acting on this drum. Therefore, there are two forces here. There is the force due to the weight of the drum acting from its center, acting downwards, the weight, and we have got the force F due to the effort applied. Now, allow me extract this circular path here so that you are able to find the distances from the turning point. So this is for that case, this is what you have. This is that circular path, then the center, then we have also these are the radius here to the step, then the distance from the step, this is it. So here it is the ground, then the step is located at this particular point here. Therefore, weight is acting downwards. On which distance? The distance is from the turning point A to this point X here. So this distance D is the distance in which the weight is acting along. I remember the distance from the ground to the step, it is 0.1, and the entire distance right from the circumference to the center of this circular path, it is 0.5. Therefore, to get the remaining distance, let's say the distance px, you take 0.5 minus 0.1 to get 0.4. Therefore, the remaining distance is 0.4. Then for the distance PA, it is 0.5, and there is another force F which is acting along that plane. Therefore, if at point A here, it's the turning point, the perpendicular distance in which force F is acting, it is along the distance 0.4 here, 0.4. Then for the case of the weight is acting along the distance, the perpendicular distance, it is D. Now using Pythagoras theorem, for that case, we will have 0.5 squared, because it is the hypotenuse, minus 0.4 squared is equals to D squared. This gives us D squared being equal to 0.25 minus 0.16, resulting to D squared being equal to 0.09. Then get the root of both sides, and our D is 0.03 meters. Now, having found all the distances we need, let's get the weight. Weight is calculated using the formula mass times gravity, and the mass is being given as 150 kilogram, then times 10 Newton per kilogram as the gravity, giving us 1500 Newton. Now, applying the principle of moments, applying the principle of moments, we will have a weight times the distance d being equivalent to force times its distance d1. For that case, we have the weight 1500 Newton times its distance, which is 0.3 meter, is equals to F times the distance, which is 0.4 meters. It's acting along the 0.4 meters. Now, for us to be able to get F, we divide both sides of the equation with 0.4 meter, entirely giving us F as 1125 Newton. 1125 Newton. The SI units for the force, it is Newton. Therefore, consider that. Let's move to question number 2. Question number 2 says locate the center of gravity of the figure below. So for the center of gravity, this is where the resultant force, the application of the resultant force due to the Earth's attraction, or where the entire weight of an object is concentrated. For this case, for us to be able to get the COG for this shape, which is a regular shape, it is a rectangle. We will get, we will draw the diagonals for each sides. So for this case, we have got 4 sides here. Therefore, let's draw the diagonals, and the point of intersection gives us the the position of the center of gravity for this diagram. So let's try to be a little bit precise. So that's the first diagonal line, or the first diagonal. So for the second diagonal, we draw it right from this corner. So those are the two diagonals, giving us this point of intersection as the position of the center of gravity for this diagram, position of the COG. So let's look at question number 3. The figure below shows spherical balls placed at different positions on a surface. Name the state of equilibrium of the ball in each example. So for the case A, remember this is a sphere. At position A, the sphere is placed on a horizontal plane, therefore it is in neutral equilibrium. At position B, this sphere is able to move a little bit when there is a force which is pushing it slightly, and it's able to regain its original position. Therefore, it is in a stable state. And for the case C, when a force is applied slightly on that spherical ball, it topples. It's not able to retain its original position after the force which is causing a slight push is withdrawn. Therefore, for that case, it is unstable. For position A, it is neutral. For B, it is stable, and for C, it is unstable. The position of center of gravity changes for that case. Neutral, remember, the COG remains. Stable, it is able to regain its original position. Now let's look at question number 4. Question number 4, the figure below shows a uniform meter rule balanced at the at 30 centimeter mark by the forces shown. Determine the weight of the meter rule. Determine the weight of the meter rule. So the meter rule is uniform. Therefore, the weight will act along its center. So let's assume that here it is the 50 centimeter mark because it is a meter rule. It's having 100 centimeters. Therefore, at the center is where the weight will be concentrated. The weight of this meter rule will be concentrated at the center. This is the pivot, the turning point. Then you have got various forces here. We have got 120, we have got the weight, we have got 30 Newton. So let's get the distances. The distance for the 120, the distance for the 120 Newton will be from the pivot. That is from the pivot, it will be 30 centimeters. We are subtracting 10 centimeters and we get 20 centimeters. For the case of the weight here, its distance is 50 minus 30, giving us 20 centimeters. And for this other force, which is 30 Newton, we are taking the distance 80 minus the center, which is 30. This gives us 50 centimeters. Now, applying the principle of moments, applying the principle of moments, applying the principle of moments, we have the clockwise. The clockwise moments are on the right. These are the clockwise moments. Then on the left it gives us the anti-clockwise moments. Therefore, uh, the principle of moment says for a system in equilibrium, the clockwise moments about a point is equal to the anti-clockwise moment about the same point. Therefore, taking the moment in a clockwise direction, we will have the weight times or multiplied by its distance, which is 20 centimeters. I add on 30 Newton times its distance, which is 50, is equals to the anti-clockwise moment, which is 120 multiply by its distance, which is 20. Now this will give us 20W plus 1500, 1500 is equals to 2400. So let's collect like terms. We'll have 20W is equals to 2400, subtract 1500. This gives us 20W is equals to 900, and if we divide both sides with 20, our weight will be 45 Newton. It will be 45 Newton. That is for the case of that problem. So whenever you encounter such and you've been told that it is a uniform metal, meaning its weight is concentrated at its center. Now let's move to the next question 5. Question 5. Figure shows a uniform metal of weight 1.6 Newton supported by spring balance at the 32 centimeter mark. The meter roll is balanced horizontally by a 1.2 Newton weight suspended as shown. Find the point where the 1.2 Newton is suspended, and part B, the reading on the spring balance. Therefore, since the meter rule is balanced, it means that the upward forces and the downward forces are equal. And again, using the principle of moments, we are able to calculate for part A, and part B will equate the two forces which are acting upwards and downwards. So for part A, this is what we do on part A. Part A, this is what we will do. So applying the principle of moments, we have the 1.2 Newton on the anti-clockwise direction, 1.2 Newton multiplied by its distance right from this mark here to the 32 centimeter mark. I can denote this as D. Therefore, its distance is D is equal to the clockwise moment. And for the case of the clockwise moment, we have 1.6 Newton. Therefore, 1.6 Newton multiply by its distance, which is 50 minus 32. 50 minus 32. So evaluating this, we'll have 1.2D is equals to 28.8. Now I divide both sides of the equation with 1.2, and this gives me the distance D as 24 centimeters. Now the question says the point where the 1.2 Newton is suspended. For you to be able to get this point, you take this distance, 32 centimeter mark, and you subtract the value which we've got as 24. Therefore, this will give us the point, and the point is, for this case, is 8 centimeter. Therefore, at 8 centimeter mark is the point where the 1.2 Newton is suspended at the 8 centimeter mark. So for question number 2, Roman B, part B. For part B of this question, we equate these two forces. Remember, there is the upward forces, which is due to the tension in this string or this spring, the tension due to that spring, and you have got the downward forces, which we are taking the sum of 1.2 and 1.6 Newton. Therefore, we say upward forces is equal to downward forces. And for the upward forces, we have the tension in the spring, T, is equal to the downward forces, which is 1.2 Newton plus 1.6 Newton. This results to 2.8 Newton. Question number 6 says, for the hammer in the figure 3.16, how large is the force applied to the nail when the force on the handle is 320 Newton? Assume the force applied to the nail is vertical, taking the length x to be 0.8 8 centimeters and y 10 centimeters. Now for you to be able to solve this, you need to apply the principle of moments. Again we apply, so applying the principle of moments, we will have clockwise moment is equals to anti-clockwise moment. And for this case, which are these clockwise? If this 320 Newton is acting vertically, it means it's acting downwards. Yeah. And there is the reaction force also acting downwards, and there is the force F due to the nail, the opposition which is offered by the nail, the force F acting upwards. So the reaction, for this case, the reaction force is equals to the force which the nail is exerting. Now the reaction force is on the clockwise direction, the reaction force. And this 320 Newton which is acting vertically, it is in the anti-clockwise direction. Therefore, the clockwise moment, which is R, the reaction force, multiplied by its distance x, the perpendicular distance x, should be equal to the anti-clockwise moment, which is 320 Newton, multiplied by its distance, which is y. Therefore, we have got R multiplied by 0.8 is equals to 320 multiplied by 10. So I divide both sides of the equation with the 0.8. With the 0.8, I remain with R as 4,000 Newton. Since R is equals to F, therefore F will be 4,000 Newton. So let's look at the next question, number 7. The figure below shows a uniform metal rod, at the center by different forces. So the question says determine the force T. Determine the force T. Now for you to be able to determine the force T, you must recall the principle of moment, and for this case we consider all the forces. So we'll go the 4 Newton. The 4 Newton is acting downwards, but in which direction? In anti-clockwise direction. We have the 8 Newton acting in a clockwise direction, but still it is a downward force. And we have an upward force, which is the tension. The tension here is acting in anti-clockwise direction. Therefore, applying the principle of moment, we have clockwise moment is equals to anti-clockwise moments, and for the case of clockwise moment we have 8 Newton multiplied by its distance right from the pivot, it is 40 centimeters, is equals to the anti-clockwise moment. We're having 4 Newton multiplied by its distance right from the pivot. It is 35 centimeter. Then we sum with, or we add with, the tension T multiplied by its distance. Its distance is 40 plus 10, 40 centimeter plus 10 centimeter. Now this will give us 320, which is equals to 140 plus 50 t plus 50 t. Now collecting like terms, we'll have 320 subtract 140 is equals to 50t, equals to 50t. Now I divide both sides of the, after subtraction I'm having 180 is equals to 50t. I divide with 50 with 50, therefore this gives me 3.6 as t. Now my t, since it's a force, it will be 3.6 Newton. 3.6 Newton as the final answer for this question. So thank you for joining. Always feel welcomed to join the Smart Science Educators program and learn more. Remember to share and also subscribe. Thank you.